So
Not what they told me in health class.
there we go. All right. Now, just as a quick review. All right. We know north is up. That is 90 degrees, correct? East is where 0 is. All right. We got north of east, east to north. Hopefully, this is kind of a review.
Oh my gosh, that's a great hiding spot.
Wait,
what? That's a great one.
Wait,
what?
It is like
You have to come on this side to see it. It's hidden in his main place.
I don't know.
Oh.
All right. A little tricky. All right. Now, looking at all the degrees, or you can just put all these degrees. Pretty straightforward, right? Hopefully that's a pretty good review, right? All right. Now, we are going to do one practice problem that I don't think we've covered. We done?
Yeah, do you need our vector labs?
I'll click that at the end.
What about the acceleration and free fall?
I think I already got that. I don't.
Yeah, you said that you collected after that.
All right, so I need the homework.
Hey guys, hey.
And all right, I'll collect that. I'll collect that here at the end. All right. Did we do example number 9? I know I skipped a few problems. Let's do example number 9 here. All right, so it's all addition. All right, it's all addition. You might need out your protractors. Handy dandy safety protractor. Hopefully everybody still has theirs. Perfect. Perfect. All right. Now, whoa, these are some big numbers.
I don't lose things that are important.
He almost lost it.
All right. So what I'm actually going to do is I'm going to adjust the numbers a little bit on your paper just because that's pretty large. So we're going to do 1.2 centimeters. We're going to change this one to 1 centimeter. And then we'll change this one to 0.7. Basically divide each one by 10. Okay? It is going to be a little one. All right. So just as a quick review, all right, got my compass here. The first one says 1.2 at 150 degrees. So I'm going to choose to start right there. All right, that's where I'm starting. 150 degrees. All right, that's way over here. And that's my start spot. All right, so I got to travel 1.2 in that direction. 1.2 centimeters. There's 1.2. Beautiful. Hopefully your first line looks something like that. Okay. Next one, it's addition. So I'm still going in the positive direction. Negative 15 degrees. Oh, okay. What will negative 15 be? I do have to flip my protractor around. Okay. It's over here. So I'm going to travel in that direction.
Why did you protractor blue? Because it's zip on, it's not actually good.
Okay. So hopefully it looks something like that. All right. 50 degrees east of north. Okay. 50 degrees east of north. So actually, I'm at the 40 degree mark, right? If we're just talking about degree, I'm at 40. 50 degrees east of north. Does that kind of make sense? Got to watch the wording a little bit. All right. So I'm going to be going up that direction, 0.7. This is a little baby dude, huh? Beautiful. So hopefully your guy looks something like that. Hey, you want to know something? I can hide this guy.
No way.
Yeah, yeah.
How did you do that?
I know, right?
Is there like a hide button or something?
All right. Now, mathematically, how would we solve this? I'm going to show you real quick. So we have our x's and we have our y's. Okay, I'm going to zoom out. So the first one says 150 degrees. Okay, so my angle was like that ish. All right. So what I'm going to do is, so what's this degree over here if I'm doing my triangle? If this to here was 150, what's this right here? 30. Very good. All right. And my distance was 1.2. Does that make sense? Yes.
Well, since that is a 30-degree there and that's 1.2, wouldn't the side opposite of the 30-degree angle be 0.6?
If you're, yes. All right. But what I like to do is SOHCAHTOA. All right. SOHCAHTOA, some trigonometry, a little review of some trig, right? Or geometry, I guess. All right. So the sine of 30 is equal to the opposite over 1.2. Okay. And then the cosine of 30 is equal to the adjacent over 1.2. All right. Going to need a calculator for this one. All right. Here we go. So sine of 30 times 1.2. I got 0.6. So 0.6 is my positive y direction because that's going up. Okay. All right. I got about 1.0. Now, my x, is my x moving in the positive direction or in the negative direction? Negative. Very good. Very good. Okay. Now we're going to do the exact same for these values as well. All right. So got to draw my triangle out. It's at negative 15 degrees. So there's 15. All right. I know my hypotenuse is 1. Same steps. Same exact steps. All right. Do you want me to show you or just plug it in? Just plug it in?
Sure.
Sweet. Okay. Sine of 15 times the hypotenuse. So my y, I got to be we'll round to 0.3. Is my y going up or down? Down. Very good. Okay. As for my x, cosine of 15 times 1, I got 1.0. Okay. So my x is in the positive direction, going this way. Okay, that's not too bad. Same thing for this one, all right? 50 degrees east of north, so that's going to actually be 40 if I'm drawing it there. 0.7, okay. Sine of 40 times 0.7. I got 0.4. So 0.4 is the opposite, and that's going in the positive y direction. Okay. And then cosine of 40 times 0.7. I got positive 0.5. Okay. That's a lot of math. Kind of hard because we didn't have any 90 or 180 degree angles. When you have those, it makes it like easy, right? All right. So just got to add them up. Those two add up to 0.5 in the x direction, and that's 1.7 in the y direction. Does that look about right? So 0.7 up, 0.5 over. Pretty close. Pretty close. Not perfect, but pretty close. All right. Now, how would I find, let's see, I found my x and I found my y. Yeah, we're good. Not too bad. All right. So that's my resultant vector right there. Now, if I have my resultant vector, I'm going to draw it larger. There's my resultant vector. It's unproportional, obviously, right? But I'm just showing you real quick. All right. I know my x is 0.5. I know my y is 0.7. How would I find theta? Yeah.
Tangent to the negative first of 0.7 over 0.5.
Very good. Tangent, inverse tangent of 0.7 over 0.5. Can you all see that all right? Good enough? I was running out of workspace down here. Bless you. All right. And that's how you get theta. Is that kind of a review? We feel kind of good on that? That's half the chapter right there.
On the quiz, can we leave it like that, or do you want us to work it out and put in a degree?
Well, yeah, put it in a degree. So like,
We circled it. So
To be sure, this is exactly what Brady and I are doing.
all right, I got 54 degrees. Rounding to the nearest whole number.
We're doing the unit circle. And
I rounded to the 4 decimal places and I got 59.6 degrees.
Brady, you have.
There you go.
Okay. Voldemort's doing the same.
Okay. Not too bad. You got a graph, Baltimore? What are you doing?
We're doing exactly.
We're literally doing cosines and sines.
Sweet.
This is what we're doing.
Sweet.
Our entire homework is just vectors tonight.
All right. So hopefully you guys are starting to get that. We'll move on. We're going to move on. All right. We are going to hit relativity. So relativity, the definition is the dependence on various physical phenomena on relative motion of the observer and the observed objects. All right. This is the easier part of the chapter. It will be. It will be.
Did we get to the theory of relativity?
This
Well, it's all
chapter,
imaginary, so.
Do we get it in this class?
Probably. I don't know, like what specific unit. But motion appears differently depending on your frame of reference. Okay, and this is what our lab's going to be about tomorrow. Okay. You know the sad part about this, though? We don't need our protractors anymore.
No.
Absolutely.
That is unacceptable.
Outrage.
It is sad. It is sad. I know.
Man.
Everybody good? All right. Nope. Free-handing it. Of course you get a protractor. Protractor, calculator, formula sheet. You get the formula sheet every test.
Even if we don't need it?
Even if you don't need it.
Like on the AP exam too?
Yeah.
Oh.
Like that is the AP exam formula sheet from last year.
So there could be more on it this year.
Or less.
It's
What did they tell us?
yeah, it's really similar. Yeah. All right. So let's talk about this question here quick. A truck is driving 40 miles per hour to the left. Okay. Yeah. All right. In the back of the truck, there is a cannon that is directed to the right. If a cannon shoots out a cannonball at 40 miles per hour, how will this look to the person observing the truck?
They don't. They don't look.
Yeah.
If the truck's moving 45 miles per hour, or 40, and the cannon's, what you got?
0. Cannonball here should just be stopped.
Oh, yeah, you are correct. Okay. All right.
Can we test that?
Yeah,
There is a video on it. It is actually.
Yeah.
That's why we're going outside, yes.
That is why we're going outside.
This is another video you made. What happened here?
I did not make this one. I do use a lot of this dude's videos.
So you're telling me that isn't you?
Oh,
Open.
Oh.
I can't skateboard.
Just do it.
Learn for your students.
I should have. That's my bad. All right, 2-minute video here. This guy clones himself too. Flipping physics.
Person taking the measurements will affect the interpretation of
Hold
the
on.
motion of the object being observed.
How do I get this? How do I get this? Give me a second. Come on, come on. There we go. Change to my speakers.
All right, I'll try again. Let's try showing a classic example. A guy riding a skateboard tosses the ball up in the air. From the perspective.
It wasn't happening with your volume up. And we're going through.
Okay, mine is ready to do it. I've had it for years.
Well, this is just an outrage. I am sorry. This is terrible. It's a really good video. I mean it.
One more. And another example.
So look, it's going straight down. You just look at, but from one place. And he shows it over and over and over about 10 more times. All right, so basically it's all about the frame of reference, right? Not too bad. We got that. All right, so let's ask ourselves some questions. If a train is moving at 50 miles per hour and a person throws a ball inside the train at 5 miles per hour in the same direction. Oh, how do I get this one? There we go. In the same direction that the train is moving. How fast will the ball appear to someone moving outside the train? Well, if the train is moving at 50 miles per hour and someone throws a ball the same direction at 5 miles per hour, how fast will it look like? 55 miles per hour. Bada bing, bada boom. If you know what I'm saying. All right. B says you can only kick a soccer ball at 50 miles per hour. Any soccer players? All right, there you go. You can only kick a ball at 50 miles per hour, but you want to impress some of the scouts by kicking a ball at 60 miles per hour. How can you do this?
Run at 10 miles an hour and then kick it.
Have the ball.
Oh, I like that. What were you saying?
We'll have the ball moving at 10 miles per hour, then run up and kick it.
Have the ball moving at 10 miles per hour.
Have the scouts run the other direction at 10 miles.
Yeah.
Or you could do that. You are correct. So there's a few options. The best answer is dribble the ball 10 miles per hour. Yeah.
You know those ramps that nailing things for concrete?
Yeah.
But you don't, it's taking your foot, so when you hit the ball, the explosive force will push the ball even faster.
I see what you're saying. I see what you're saying. All right, next one. Next one. If a quarterback throws a football 30 miles per hour to a receiver that's running towards the ball at 10 miles per hour, how fast is it from the receiver's point of view?
So I wasn't going to answer that.
Oh, I was really hoping you were.
Okay, what was the question?
40.
40.
So the quarterback threw it 30. I'm running 10 towards it. If you add those two together, it's coming 40 miles per hour.
But aren't they?
They're in opposite.
So
Yeah.
you had no matter what?
Yes.
Okay.
So
Unless if you're running away.
baseball.
Yeah, unless you're running away on this one.
Because it's coming at you.
Because it's coming at me,
Okay.
it increases the speed. It's coming towards me. Yeah.
Okay, so in baseball, if you're the batter
Batter.
and you want your off the bat velocity to be faster, can you like sprint at the pitcher as you hit the ball?
Well, that's why you take a
I mean,
step
that's
forward.
what.
Yeah. Oh my God. Yeah. Happy Gilmore, but in baseball.
That's why a lot of softball players do that.
Do they really?
I mean, they actually do that, but they do it so that they get a running start to first base.
Oh. Well,
So like, but if you were running towards the baseball, wouldn't it make it seem like the baseball is coming faster?
Yes.
Well, wouldn't it be a lot harder to hit the baseball?
Yes.
So like, there's a,
But it does sound like a good idea, right?
Yeah. You just run the first into the hit.
All right. Some more examples here. Some more examples. A moving sidewalk in an airport. Oh,
Those are neat. I like Boston.
guys, let's quiet down. Let's quiet down. A moving sidewalk in an airport terminal moves at 1 meter per second, and it's 35 meters long. All right. If a man goes toward the sidewalk at 15 miles per hour and steps onto it without changing his motion, how much time does it take him to reach the other direction? All right. So the first time, let me flip my paper over. The first time, he is moving in the same direction as the sidewalk is moving. Okay. So the sidewalk is 35 meters long. Let's see. So the terminal moves at 1 meter per second. All right. So he's moving 15 meters per second in that direction. The sidewalk moves 1 meter per second in the same direction, correct? He's going the same direction. So if you combine those two, that equals meters per second. Now, how many seconds will that take him? Well, you're going to have 35 meters. Do the little conversion. For every second, you travel 16 meters. I got 35 divided by 16, 2.2. Takes him 2.2 seconds. That's pretty good time. Now, when he is traveling in the opposite direction, so let's say he's traveling 15 meters per second here. Oh, you can't even see that. Could you even see me work out the other problem?
Yeah.
There we are. Let's say he's traveling 15 meters per second. However, the belt is moving 1 meter per second that way. So what's his total? 14, right? So once again, 35 meters. But this time he's going 14 meters per 1 second. I got 2.5 seconds. Right?
do the same thing, like going up an escalator.
You're not supposed to
Kind of.
move the sidewalk.
Yeah. Okay. How are we feeling?
15 meters.
All right. Good, good.
That's like that's a walk.
All right. I'm hoping this video is going to work.
Meters per second. That's like the length of this classroom in 1 second.
That's possible.
That's what Usain Bolt does. My video is really.
Literally,
I think he's
literally Usain Bolt is on the plane to the Olympics and he is like.
Why is he going out? I feel like
It's going to be better. I know it.
trees.
So they're traveling very different speeds. However, one's obviously going a lot faster than the other one. Okay, we can clearly see one going a lot faster, right? Does it look like the Prius is moving? If you literally just focus on the Prius, that is not moving. All right, that van's cruising pretty good, huh? All right.
I want to see the minivan doing donuts around the Prius while also going forward along with the Prius.
All right. So that I just want you guys to see that so you guys have an understanding of kind of what it looks like. All right, hopefully we're starting to get it. Oh. All right. This is going to be our last question. Last question. All right. You are driving with a speed of 40 miles per hour relative to Earth. The car next to you, car number 2 over here, is traveling with a speed of 25 miles per hour relative to Earth. Okay. Lastly, the truck in the opposite lane is traveling with a speed of 30 miles per hour relative to Earth. Okay. So what I like to do, I'm going to write down all my numbers that I know of. Okay. So truck in the left-hand lane, it is traveling in the opposite direction of 30 meters per second. All right. I am driving this direction at 40 miles per hour. Or what's it? What? My bad. Miles per hour. I'm going 40 miles per hour. Okay. And I'm passing a car that is going 25 miles per hour relative to Earth. Okay. From my point of view, what is the velocity of car 2 and the truck? From my point of view, all right, this is me. I'm going 40 miles per hour this way. Well, according to my speed, this is actually going backwards, right? Yeah. It's kind of going slower. Like I'm driving and it's kind of going behind me, which means that's going to be negative. What's our negative velocity of that car going to be? Of this car? 15, negative 15 miles per hour because it's going behind me, right? I'm passing it. All right. Now for the truck, how fast does it look like I'm going for the truck? This is kind of like the football question. If I'm going 40 this way, the truck's going 30 this way, 70. The truck looks like it's going 70 miles per hour.
I'm gonna drive home and think about this the whole way.
Yeah.
Yeah. Like I'll be like, okay.
Say what?
Wait, is that so? Like, if a cop, Mr. Bowers,
No, just be positive. I think. What's my answer? You are correct. All right. That's my bad. I was wrong. It is negative 70 because once again, it's going behind me. Thank you. Thank you. Negative 70. Yes.
So, I don't know if cops can do this, but if you're driving, like if you're passing cop like this,
Yep.
right, like the truck,
Yep.
can they use the speedometer
Yep.
to still get you?
Happens all the time.
Are you serious?
Yep.
So
They will have to subtract their
Yeah.
speed. But like, how do they do that?
But it won't.
They don't even try.
But
But like, wouldn't that be not very accurate? They have to subtract their speed.
It's more accurate than you think.
Huh. Okay. No.
Like if they're on cruise control, that's why I like to drive. Wow, never mind. If cops are driving in the opposite direction, it's hard for them to get cars in the right hand lane. What their speedometer is going to be picking up is the cars in the left hand.
Because like I've always passed cops on the other side of the road, and I'm like, oh, they're
Not if you're going fast.
Life hack. If you're in between lanes, they can't get a good reading.
All right. From the truck's point of view, so I'm looking at this guy now. What is the velocity of car one? I am car one. Same answer, right? Negative 70. Because from the truck, car one is going behind me, negative 70 miles per hour. What about car two? Negative, I heard it. What did you guys say? 55, there it is.
Wait.
You're getting closer.
Okay. Guys, that's the second part of the chapter. That's our chapter right there.
This is our chapter?
What's our quiz gonna be on this?
Lab tomorrow, finish the lab, review Wednesday, Thursday. But it's not like a test, it's a quiz. But it's like a quest.
Those are always worse than a test. I don't know why. It's not
Interesting. You haven't had one of my quests before then. All right. You guys can clean this up. Taylor.
So on part A of that example,
Yep.
truck be going 70 miles per hour or negative 70?
Negative 70 because it's going behind you. Yeah. I do want to collect your lab and homework. I would love to.
For the, I didn't get the final, your recording.
Oh yeah.
All right, give me a second.